Hi there, welcome to Something of Everything. In this video, we will see how to define seismic parameters and apply seismic mass in order to calculate the seismic loads in STAAD Pro. Let us first see how to define the seismic parameters. In General tab, load definition, in the second load definition window, there is seismic definition. Just edit and change it to Indian code. You can provide seismic definition as per the country. We are giving seismic parameters as per India. You can generate it. In generation case, you will get a generation window like this, and you can define the city and all, and you can generate the seismic definition. Seismic parameters. We are defining the seismic parameters manually. Let's say our building is in Ahmedabad, then the zone factor will be 0.16. The response reduction factor. You can read about each factor from the help menu in the given table. Response reduction factor as per table 7. For general buildings, it is for RC special moment resisting frame, and if you are doing the ductile detailing, you can give 5. Importance factor. For general buildings, it is 1. For important building, it is 1.5. You can get the importance factor from table 6 of IS 1893-2002. Okay, in our case, the importance factor is 1 only. Then rock and soil factor. Rock and soil factors, depending on the type of soil, average response acceleration coefficient is calculated corresponding to 5% damping. Let us say our soil type is soft soil, so we have to give 3 in the soil factor. Okay, then type of structure. You can see for RC frame buildings it's 1, for steel frame buildings 2, for other buildings it's 3, and for stack-like structure it is 5. In our case it will be 1, as it is an RC building. Damping ratio. Damping ratio to obtain the multiplying factor for calculation of SA by G for different dampings. In our case, the damping will be 5%. That is why we are giving 0.05, and this is the default value. For steel buildings, the damping ratio will change as per 1893, and you have to change the same here. Px and Pz are the time periods that you can give as per IS 1893, or you allow the STAAD to calculate the natural frequency of the structure and use it for calculating the SA by G. Okay, let us use STAAD itself for calculating the natural time period. Okay, then DT, depth of foundation. If the depth of foundation is more than 30 meter, the AH value will be half. In that case, you can provide the depth of foundation if you want. If you want to provide it for lesser value also, you can provide it. In our case, we are just ignoring to provide it. Ground level. You can provide the ground level below the support. And spectral acceleration. If you are not given the SS, you can provide the SA. The multiplying factor for SA. Coefficient CS, area of cross sections, multitudes of elasticity, etc. You can provide every parameter based on this technical definitions. That is the topic number 5.31.2.5 in STAAD help menu. Okay, as we have defined the parameters, let's add it. Now that the parameters are added, all you have to do is you have to apply the seismic mass in order to get the seismic loadings on the structures. You can provide seismic mass by 3 different methods. One is member weight method, other is joint weight method, and the third one is reference load method. Let us see one by one. Member weight method. As you have provided the loadings, that is dead load and live load. We have provided live load in 3 sections, that is live load less than or equal to 3, live load greater than 3, and live load on roof. Why we have done like this? Because as per IS 1893, if your live load is less than or equal to 3, all you have to calculate for seismic load is 25% of live load. If your live load is more than 3, you have to take 50% of live load in seismic loading. If your live load, you can ignore the live load on terrace. That is why we have differentiated it in order to give it in the seismic mass definitions. Let us give it. How we can give the seismic mass based on member weight method? Just go to the input file, go to the loadings, as you have given this in dead load. All the dead load will come in the seismic mass. In live load section, live load less than or equal to 3 will come 25%, live load greater than 3 will come 50%. You don't have to give the live load of terrace in the seismic mass. Okay, let's just do it. Below dead load, just copy all the loads, copy it, and below the seismic parameter, paste it. You can write out in comments that these are the seismic weights. All you have to do is you have to create it in the mass. The mass will be positive and there will be no direction for mass. All you have to remove is the GYs and the minus sign in case of floor weight. Remove them. Okay, what we have done, we have just copied and pasted the forces, right? This is self weight, no need to give anything. These are the floor loads. In that case you have to write floor weight, GT, above it, and we have to give the member loads also. Make sure you are giving seismic mass in a sequential manner, that is self weight first, joint weight thereafter, member weight thereafter, and floor weight at the last. So we are pasting the member weights above. Instead of load we have to write weight, and we have to remove the minus and GY. Yes, you got it right. Okay, now the member weight has been completed, floor weight has been completed for dead load only. All you have to take is for the live load also. These are the live loads. In the floor load you have to give the live loads, right? That is floor weight of live load. Okay, just paste it. Remove the floor load and change it to floor weight, right? I think there should be floor load here, it's missing. Okay, no issue. Floor weight, remove the GY and minus sign. Okay, now that the seismic mass has been created, just save the input file, close it. Let us see if there is any error. There isn't any error, and here it is. This is self weight, member weights, and floor weights. The definition has been completed. All you have to do is you have to apply the seismic mass in the cases. In EQX, just add it, go to seismic loads, in X direction 1, just add it. For Z also, EQZ, add it, seismic loads in Z direction, that will be 1, add it. Now that seismic loading has been done, we have to give perform analysis command after this. Perform analysis and change command after it. Okay, This has gone at the last, as you can see. Okay, that is okay, no issue, but change is not required there. All we have to give is we have to give Seismic a perform analysis command below the loadings, right? That is EQX. You will want a command there. Add after current and change also after current. In that case, this has gone above it. All you need is you need below this. So select it and define the command, and then add it after that. It's not going there. Just select this and add. What happens? Okay, it has come, right? Let's give the change command also. Okay, all you can do is you can just go to input file, loading 1. As you can see, the perform analysis change has came. Just copy it, paste it in the Z direction also. Sometimes changing in input files are much easier than changing it manually from the GUI. Okay, now that we have given everything, let's just analyze it and see what happens. It says some of the load cases are empty. Let it be. You don't have to worry about it. Yes, as you can see it, right, we don't have created the combinations. Let's see what the error is. Seismic sulfate 1 density is not provided. Yeah, as in the hurry we didn't provided the densities, that means material properties, to the structure. Let's give 450 by 450 of column and 600 by 300 of beams. Okay, just assign to edit list. No, let's select by the groups. We have created the groups for columns as well as beams. For columns, and this is for beams. We have to give this for beams. Okay, as you have provided the properties, you have provided the densities. You can change the density as the analysis has been done. Now that we can see the loadings, just press the loads and you can see it in the EQX. You can see the seismic loads. If you want to see the values of it, just press Shift V and the seismic value is being seen. This was the method of application by member weight. Let us see the other method. Just remove the seismic weights. Okay, in other case you can apply the seismic weights, seismic mass, by joint weight method. In that case, all you have to do is you have to provide hinges at the column junctions so that you can get the weights at that points and apply that as seismic mass, joint weights, in order to get the seismic loading at the joint points. Let us do it. Let's select beams parallel to Y, that is columns, and let's apply hinges at the junctions. Okay, now that you know that all the beams junctions are hinges, this is the hinge model that you have to prepare in order to get the seismic loadings, or say the weights at that points. Now analyze the structure, but in that case we have to give a load combination, a combination that will give the seismic weight, joint weight at that node for your necessity. Let's define the combination. That will be DL plus 0.25 LLL3, that is live load less than 3, plus 0.5 LLG3, should be capital G3, plus no, there is no requirement of live load of roof, that you can ignore. You want it full, you want it only 25%, you want LLG3 as 50%, and add it. This case will give you the seismic joint weights for applying in the STAAD Pro. Okay, now analyze it. You don't have to worry about the empty case. Let's see what the error is. No loading defined under UBC. As you have not defined any load in the UBC, the seismic loads EQX and EQZ will create the errors. In that case, just apply the self weight under the seismic definition so that you can bypass that error. This is just a cheat sheet, you can say. As the analysis has been done, all you have to do is you have to open the Excel. Just go to cross processing, select the load combination that is being created for seismic loads, and just click on reactions. As you can see that these are the seismic loadings. Just select it, copy it, go to Excel and paste it. Now that you know that these are the seismic weights of that joints that you have to provide as joint weight in the STAAD Pro. All you have to do is you have to go to formula and click on JWE, and the joint weight are created and copied out. Let's see it again. You can get this add-on from us. Just go to tinytopic.in and contact us. It's of merely 50 rupees only. Just click on JWE and your joint weights are created and copied out. All you have to do is just go to input file, under the seismic definition, that is seismic parameters definition, remove this self weight that you have used for bypassing. Just write a comment that seismic weight, okay, and paste it. These are the joint weights that you have to use in order to calculate the seismic loadings. Now that your purpose is solved, all you have to do is you have to give no support to the whole structure and the fixed support to the bottom side. And the joint weight method is completed. You can get the joint weight extraction add-on from us. Just go to tinytopic.in and contact us. Just analyze it and see the loadings. Just press on loads. This is not the seismic load. Let's see where the seismic load is. This is the seismic load, right? As you can see, you can reduce the scale so that you can see the seismic loads clearly, right? These are the seismic loads. Yes, that's it for up to these two methods. We have learned member load definitions, member load method for seismic load calculations, and joint weight method for seismic load calculation. Now is the time for the third method. You can see in the below commented list, below description list, for buying the joint weight extraction add-ins. Okay, let's learn the third method. Let's delete out these joint weights in order to give loadings by third method. The third method is reference load method. In this method, you don't have to try any of the above two, that is member weight or joint weight. All you have to do is you have to define the loadings in the reference load itself and refer those loadings every time you want to use it. Let's see how it is. In that case, you have to give reference load definitions for what? That is DL. Okay, edit and live load LLL3. Yeah, you got it right. We have to give it this way only. And roof live, that is LLT, and edit. Okay, now that you have defined the seismic reference loadings, all you have to do is you have to give all these loadings in this reference load itself. If you have given it in the normal load cases, just go to it. Where is it? This is the right. Just copy this, and I guess you are guessing it right. Go above and below reference load, just paste it, and the reference dead load is created. You have to remove it from normal load case. In such a case, cut paste would be better, I guess. Happens. Let's cut it and paste it. Cut and paste. Now that the reference loadings has been given, as you can see all the loadings has been applied in reference loads. All you have to do is you have to refer those loads here. R1 is dead load, R2 is LLL3, R3 is LLG3, R4 is LLT, and you are applying dead load. You have to refer those loads. Just go to repeat load, reference load, that is dead load, and just add it. That's it. All the dead loads has been applied. In LLL3, just go to repeat load, reference load, LLL3, press this and add it. LLL3 has been applied. LLG3, we have not given any reference load, but we are applying in the section. In LLT, repeat load, reference load, LLT, and add. Okay, reference load has been applied, right? Let's see what happened to LLG3. As we have stopped it, it's not being seen. I will see correctly. Okay, after you have applied the reference loadings, you have to give the seismic weight based on the reference loads. Just edit, go to reference load, press on DL. We want DL full. We want LLL3 also, but in the 25% only. We don't want LLT, we want LLG3 in 50%. And what we want seismic mass in y direction. Okay, it's completed. Just analyze it, and then just wonder why. Let's see what happened. Case being factored does not exist. Okay, as we have given LLG3 and there is no loading in LLG3, and the case being factored. Okay, if you have not given the LLG3, just remove it from here and analyze. Let's see if it can do. Case being factored does not exist. I guess it is existing. Why it is doing so is matter of question. Let's change it again. Okay, this is 1, this is 0.25, this is 0.5. We don't want to give this is 0. Cannot be 0, right? It was just a trial. It should come. Why it's not coming is a matter of question. Let's see what happens now. It's an error. Case being factored does not exist. Why being so? Okay, we got it. As you can see, where are the reference loadings? Here. Where is the seismic definition? Here. Reference loadings needs to be above the seismic loadings because STAAD reads from top to bottom, and when it is coming to seismic definitions, it can't get the reference loads. Just cut it from the below and paste it above it. Now that you have changed it, it should work now. Yeah, it is working. STAAD makes you a bit smarter every time you do it. Okay, let us see the seismic weights. These are not the seismic weights. This is the seismic weight. Just change the scale, like in labels, scale, and do it 0.5. Let's see. Let's do 1. 1. Apply it. As you can see, the seismic load has come. Thank you for watching, guys. In this video here you have learned from start to end of seismic loading definition and seismic mass creation and application. By these methods you can apply seismic loadings for static analysis. Thank you for watching, guys. To like, subscribe us, and yeah, don't forget to share this with your friends. Thank you.